Hello everyone, hope you had a great snow day. I am sending you this I hope to be a little 5-minute video to help you think about where we're headed tomorrow. We have reviewed how to factor. We've learned how to factor difference of cubes, sum of cubes. The real purpose is for us to be able to take higher order polynomials, reduce them down, and find all the solutions, find where the points where the graph crosses the x-axis. So our goal for this lesson that we're going to talk about tomorrow is to use synthetic division to reduce a higher order polynomial down to a quadratic level or sometimes even a linear level. This process of reducing the polynomial is called depressing a polynomial. The reason that we want to use this technique is to ultimately help us find the solutions, and that's going to be our ultimate goal in the next coming days. Once you depress a polynomial to a quadratic or a linear level, it's easier to find the remaining factors, which makes it easier to find all the solutions, and that's going to be our ultimate goal. So let's take a peek at two examples real quick, and we're going to be using a lot of the processes that we have used before, namely synthetic division. Remember that when we're given a factor, we're going to take whatever the divisor is. Let me highlight that divisor real quick for you. This is the divisor, and we're going to take that divisor and we are going to place the opposite of that number outside the box. That's a 5. Then we're going to use the coefficients of our dividend, this polynomial here that I'm underlining, and we're going to use synthetic division to reduce it. That's a 7, and a 15. Right? With the process of synthetic division, you bring it down the first coefficient. You multiply the numbers that are outside the division box. So 1 times 5 is 5. You add it to the number in the next column. So that leaves -2 as the sum. We're going to multiply -2 times 5, which is -10. We're going to add it to 7. That leaves -3. We're going to multiply -3 times 5, and that gives us -15, which means we have a remainder of 0. So the factor theorem says that x minus 5 is a factor because the remainder is 0. The next thing that means is that this depressed polynomial, x squared minus 2x minus 3, is going to be where other factors come from. So this is a factorable polynomial. So let's factor it. We're looking for two numbers, grab my highlighter real quick, that multiply to 3 and multiply to -3 and add to -2. So that will be x minus 3 and x plus 1. These are the remaining factors. Whoops. Remaining factors. To list all the factors, you would have to include the x minus 5, the x minus 3, and the x plus 1. These are all of the factors. Now you see that we're in a great position to solve and find all the zeros, because we can then set each one of those factors equal to 0 and find all the solutions, and that's where we're headed in the next couple of days. So keep in mind the ultimate goal. One more illustration, a sample, and we're going to take 3. That's what we're going to divide by. And we're going to put our coefficients inside the box. We're going to bring down the first coefficient, multiply, and add. We're going to multiply 3 times 7, and we're going to add it to negative 15. We're going to multiply 3 times 6, and we're going to add it to negative 18. That gives us a remainder of 0. All right, the factor theorem says that if the remainder is 0, then x minus 3 is a factor, which means that x squared plus 7x plus 6 is a depressed polynomial. Let me erase that. That looks really bad. That's our depressed poly. Then our other factors are going to come from. We look at it and we can recognize, well, this is factorable. This is a trinomial, and that's going to factor into x plus 6, x plus 1. So these are the remaining factors. And then all the factors are going to be x minus 3, x plus 6, x plus 1. These are all the factors. All right, so that's where we're headed. Thanks for listening. Hope you had a great day. I'll see you tomorrow.